Hello, welcome to All Systems Go, the 2022 Netreo User Group Get-Together. My name is Kyle Jackson, and I am the Retrace Customer Operations Lead here at Netreo. My session today is going to be covering Retrace 101, maximizing your capabilities with Retrace APM. Retrace is an easy-to-use SaaS application monitoring tool. It combines APM reporting with centralized error and log management. The main component of Retrace, the APM feature, provides code-level application performance visibility for 6 of the most popular programming languages: .NET, Java, PHP, Python, Ruby, and Node.js. Retrace APM metrics give users insights into the amount of requests that are being made to an application's endpoints and how those requests are performing. Now, we're going to jump into the Netreo sandbox for Retrace that we maintain so customers can get in and play around with Retrace and see what it has to offer. That looks just like any normal client account that you may set up within Retrace. From there, we're going to discuss a little bit about the installation of Retrace and the configuration of applications to appear in Retrace. And then I'll cover an applications dashboard where we'll look at the APM and what types of information are reported in those dashboards so that you can see where that valuable metric information from your application's traffic will be reported. This is the Retrace UI. The applications that you see listed on this screen are all different applications being reported to Retrace from an agent that's installed on the server where they're running. Retrace can be installed on both Windows and Linux servers. Retrace can also be used in Azure and AWS environments, in Docker and Kubernetes containers. Once the Retrace agent has been installed on your server, in today's examples, we're going to be talking about .NET applications on a Windows server. You'll want to configure your application to begin reporting to Retrace. Since we're talking about a .NET application running on a Windows server, the way to configure that application would be to create a JSON file saved to the root of the application that we call the stackify.json. In the stackify.json, we ask you to set an app name specific to the application the way you would like it to report in your Retrace account, as well as an environment name. This helps us place the application strategically in your account so that you can view applications as their own instance or group together in a single instance when you have them running on multiple servers, but they're the same application. Now, this might sound a little strange when you think about the way you use environments. You may use production, staging, development. In Retrace, those are still very important, but when we talk about Retrace environment settings, it's specifically to allow you to customize the way the application will show up in your account. Now, once your application's been configured, it's running on your server, and your server has the Retrace agent installed, Retrace takes over from there. Retrace has a profiler as part of your agent installation that will attach to your application and begin monitoring the request throughput that is sent to your application's endpoints. That is where you start to get some of the APM metrics that make up the screen we're looking at now. Just to cover the web apps dashboard briefly, you get the app result, again, the name of the application followed by the environment in parentheses, what type of application it is. In this case, we're talking about an IIS web app or a .NET application. How many instances of this application are being monitored in this specific app result for the example.net app that we're looking at, there are 2 instances, and then some basic APM data metrics. First is the requests per minute that have been reported over the last full minute. Right now, we're seeing 9. And the satisfaction of those requests. Satisfaction is just a measurement of the speed of the request for the end user. It's based on 4 different categories: fast, sluggish, slow, or failed, and essentially just tells us whether a specific request performed either faster than a certain goal time, sluggish to a certain goal time, slower than a specific goal, or if it failed altogether. And then the last metric here is errors per minute. How many errors were profiled over the last full minute by the APM? In the case of this example.net app, there weren't any errors picked up. The features category details out to us what features of Retrace are currently in use. The bug represents errors, the logs obviously represent logging, and the gauge represents APM data. When all 3 of these are present, that means Retrace is currently profiling and reporting each item from those 3 categories. The alerts column signifies how many alerts are currently active for a specific application and what level alert they may be. The first box is for warning alerts, the second will be for critical alerts, and the third will be for outage alerts. To start to dig into what type of information is being reported for a specific application, all we have to do is simply click on the name of the application we'd like to get more information for. Once I click on the name, I'm going to be loaded into what we call the applications dashboard. So now we're viewing data specific to the example.net app in the environment full framework. The information we're going to see reported in this dashboard begins to be broken down into separate categories by its data type. First is the dashboard tab. This tab is a general overview tab. It gets us more information about the health, performance, and error information that are being reported inside of this dashboard. The second tab is a monitoring tab. This is specific to this specific app instance and resource information. It will tell us things like what servers are this application running on, any key transactions that we've configured for this application, and any error rate information we have for this application. Now, anytime you click into a dashboard in Retrace, you're going to be defaulted to the last 4 hours of information. This helps us give you the most recent snapshot of how things are performing in your application. We do offer some different preset times that you can choose from, but last 4 hours is the default, though you have options to view the last hour, the last 24 hours, yesterday as a whole, the last 7 days, or last 30 days. You can also select a custom range if you're looking for a specific time point at the bottom of this selector. But if the time that you're wanting to view more information on is already present on the screen, we do offer a drag and click option that will allow you to zoom in to any snippet of time that you'd like. As an example, if I hover over 1300 on this graph, I click and hold and drag to 1345 and let go. That's going to automatically zoom me into my selection, allow me to see metrics in a more granular view. And then when I'm done, all I have to do is grab that time frame selector and I can jump right back out to the last 4 hours. Now, the APM tab is going to have some different information reported throughout it. First, the charts that we see. The first chart is a server breakdown. This is just a breakdown of the different parts that occurred on the server side of the request when a request was made to your application's endpoint. This is going to be for items such as space timings, .NET code timings, any tracked functions that you've added to your code using the Retrace documentation, and then any external web service calls. All of these pieces of information are going to be calculated and reported to you on their average load time, and then displayed in this graph that you can then hover over and see the specific timings of each individual piece from the reporting of the graph. In this case, when hovering over 1258, I can see for all of the requests for my applications on the server side, my total average load time was 3.718 seconds. Sorry, I moved a little bit there. My average database time was 1.579 seconds. My average .NET timing was 2.13 seconds, and so on. I can also see that I had 13 requests at that given data point total. Now, I also have options for client breakdown graph, and essentially that is the same thing as a server breakdown, but rather than being on the server side of the code, it's going to be on the client side of the code. We also refer to this feature as RUM, Real User Monitoring. It allows you to get more information on what's going on that client side of the request. We also have a graph for user satisfaction. And this goes back to when we were on that web apps dashboard and we were talking about the satisfaction of the requests per minute. That is where this information comes into play. Now, user satisfaction, again, this is a measurement of how a request performed for the end user based on a goal. Now, in this case, the goal time is 1.75 seconds. Our default goal time is 2 seconds, but we allow you to customize the goal time to fit your specific needs. When thinking about satisfaction and how it compares to a specific goal, that is how we break down whether a request would be deemed fast, sluggish, slow, or a failure altogether. On a 1.75 second goal, fast requests are going to be requests that are in the fastest fourth of your requests. Faster than 1.75 seconds, on average, they're going to be faster than a second altogether. Your sluggish requests are going to be anything on the latter side of that lower than 1.75 seconds. So when we think about fast, we're thinking about anything from 0 to 1. And we're thinking about sluggish, we're thinking about anything from 1 to 1.75. Slow is going to be any successful request that was slower than the goal time, and then a failure is obviously going to be any request that did not successfully return a result. The nice thing about being able to see the satisfaction of your user requests is it gives you a visual example of what your users might be experiencing at the time when your application may be experiencing issues, and then how they may be experiencing the application when there are no issues internally within your application. Below the graphing that we see here, we break down the APM information by category and give you some more specific results for those different categories. The first tab is going to be the overview tab, and it's just a quick snip of the top requests or the top SQL queries that occurred within those requests. Additionally, there's also top 5 lists for external web service calls and top 5 track function calls that are taking place in the application. The information included on this overview tab is the same as what you'll see in the information within those actual tabs above. So your requests will show up in server requests, your SQL queries and SQL queries. This just limits it down to the top 5 based on either the percentage of time they were called or their average page load time. You're able to select how you view these top 5s. The next tab within the APM information is going to be the client requests or your RUM data. We're not quite talking about RUM data. It's very similar to APM, but since we're not talking about it today, we'll go ahead and skip over it. but RUM is available in Retrace. It's currently in a closed beta, but our product team can enable it for you if you'd like to try out RUM and get an idea of what information you can get from that client side of things. Server requests are going to be the requests that took place on the server side, how they performed when requested from your application by your end user. When we click on server requests, the first thing we're going to see is that we've got an option to filter by URL. So if I wanted to search all of my requests by URL, I can do that and return just the individual results that I want for a specific piece of information. Or I can leave the search blank and view all the requested actions that have occurred in the time frame that I'm viewing. Now, again, we're viewing the last 4 hours of information, but if I wanted to open that up to last 7 days and view the last whole week of information, I could do that as well. Now, below, I'm going to see requested actions listed out from the application's endpoints. So I've got a home.about, a stackify.slowdb, and a home.swallowed exception. These are all different endpoints within the application that we're monitoring that are being hit by traffic and having APM data returned for them. My application may have 1,000 different endpoints within it. I'm only going to see reporting for those endpoints that have had data profiled for them in the time frame that I'm viewing. Now, if I have a home.contact us page that hasn't been hit in the last 4 hours, I wouldn't see it here in this reporting because there wouldn't have been any data for Retrace to upload for that endpoint. But any endpoints that have received traffic over the last 4 hours are going to show up in this reporting. We're going to list out how many requests were made to it in the time frame that we're viewing. You'll notice for home.about, this top requested action in the results list, I've got 1,192 total requests to this endpoint in the last 4 hours. They were called 31.3% of the time, and cumulatively, those 1,192 requests have an average page load time of 3.10 seconds. Those are returning a 69.5% satisfaction score based on that 1.75 second goal time that we're scoring the satisfaction on in this application. And I've got just below 1% failures. So about 0.7% of the requests that have been made out of that a little more than 1,100 requests has actually failed. Now, this is just some base default information that Retrace shows for any normal application that you add. But you have some additional metric options that you can add to your view as well. If I select Edit Columns, I can add in timings for database, queue, Redis, storage, and web external. It depends on the framework of your application. In this case, .NET framework, these are going to be the columns that are available to me. But if I was on a Linux server using a PHP application, I may have different columns that I can add into this APM reporting. To add in any specific column that you'd like, you'll simply grab the edit column option, click database, and then click off, and that will bring up my database information and how the database has performed from that requested action in the time frame that we're viewing on average. Now, again, a lot of this information is average timings. They're not specific to run requests because we have so many requests. We're combining them and giving you an overall average of that information specific to that request to keep you more informed about how an endpoint is doing altogether rather than how an endpoint does each time it's requested. I can also get additional information for any one of these specific requested actions simply by clicking on the name of the requested action. That's going to load what we call a requested action detail or a performance detail for the specific endpoint that I've selected. When I open a performance detail, again, I'm going to see what requested action that is. In this case, the get home.about, and then I get some specific information to this requested action. Now, the user satisfaction section of this individual request detail, it's going to be different than the user satisfaction chart we were viewing on the previous screen. And that's because the user satisfaction that we're viewing on this specific window is only for one specific requested action. Now, all of the data is specific to home.about rather than all of the endpoints combined and averaged out. Here, we're able to see how this requested action does, whether it's fast, sluggish, slow, or it failed, and then how it performs broken down based on that goal time of 1.75 seconds. So we can see for home.about over the last 4 hours, we're averaging about 3.4 seconds of average load time. We've got about 4.6 requests per minute, and those are returning a 66.367% satisfaction score. Now, again, that's all based on this 1.75 second goal time. Now, we talked earlier about how 2 seconds is the default goal and how you can change that for your entire application. We also allow you to change this goal time for a specific request individually. So, as an example, if I wanted my entire application to run on the default 2 second goal time, I could leave that in the overall graph reporting that we were looking at previously. But if home.about was a request that generated some sort of report and it took longer, and I know that it's going to take longer, but I don't want my satisfaction score to be hit over and over and over again every time that request is made and has to generate that report that takes, for instance, 10 seconds, I can account for that in Retrace. All I have to do is load the specific request detail as we are here, come to the user satisfaction column, and then edit the goal time for this endpoint. Now, if I were to change this goal from 1.75 seconds to 10 seconds and then save that change, when we return to the previous screen and we're looking at the user satisfaction graph, the 1.75 second goal time for the application itself would remain at 1.75. We would have only have changed the goal for home.about to 10 seconds, allowing us to adjust our scoring system just a bit to make up for the fact that we know that request is going to run slower because it's generating a report. Also, in the individual request detail page, I'm going to get a server breakdown or a performance breakdown of how things performed on the server. I can see, again, the .NET timings, the database query timings. I can see external web service calls and how they performed, how many calls were made to those external web service calls. And then I can see the database connections. I can see it open, I can see it closed, and I can see specific logged events that I've added into my code. Across the graph, you'll notice you also get these little lightning bolts. Now, a lightning bolt indicates that a trace detail was profiled and reported for the request made at the time that the lightning bolt is associated with. So it hover over one here, 1237, I have a trace detail from this application, from this specific endpoint, that I can view that will give me more information on how that one request performed. Now, if I scroll down, I'll eventually get to traces. And here you'll see I've got reporting for trace details. The slowest trace that's taken place in the time frame that I'm viewing, in this case, we're still viewing the last 4 hours. The fastest trace that took place in those 4 hours, the last trace chronologically that took place, and then a list of all of the trace details that were reported for this specific requested action. Now, this is important Retrace does not report one-to-one, and that's to say one trace for every one request made to an application. Rather, Retrace samples your traffic, samples the traces, and looks for context and reports your outliers. Was the trace slower than the typical trace from this endpoint? Was it a lot faster than the usual trace? Did it introduce new SQL or a new exception? Those are the traces that are going to get reported. You can expect with consistent traffic to an endpoint that Retrace is going to generate one trace every 5 to 15 minutes. The higher the traffic to an application, the more traces that application is going to report in Retrace, and the more traffic going to a certain endpoint, the more traces you're going to see. Now, you may have endpoints that are getting 1,000 requests an hour, and you may have endpoints that are getting 5 requests an hour. It's likely you're going to see many more traces for that endpoint that's being hit 1,000 times than you would get for an endpoint that's being hit only 5 times or so an hour. So looking at the trace details, we're going to look at the fastest trace that's been reported over the last 4 hours. Now, the trace detail is going to break down everything that happened in that request cycle. So the trace occurred at September 1st at 11:35 a.m. That's when the trace takes place, and that's when the steps begin. So first, we're going to read the request. The second step, the async controller action invoker takes place. So we invoke the home action. The SQL connection opens. We execute the SQL command. We can see what that SQL command was. We can see HTTP client send async runs, the send request and receive response runs from the external web service call to the Sandbox API on Azure. We can see the handler execution step. We get a view results, and then it's all packaged into a send response output. All of that took place in about 20 milliseconds, so very, very quickly. On the other hand, it could have been a slow request. It could have been the slowest trace in the last 4 hours, and we may have several steps that took thousands of milliseconds. So it's going to be very dependent on whether or not that request performed very well or did not perform well at all. That's the context that Retrace delivers, rather than providing a one-to-one trace detail where you're getting 998 average trace details, one slow one and one fast one, that you then have to sort through. So that's kind of the purpose behind the sampling that Retrace does when it comes to traces, is to provide you as much context from the information that we're reporting to you as we can, without you having to filter through all of the less important, more average information that you already know. The next tab in APM data is going to be for SQL queries. With SQL queries, just like server requests, we're able to click and view the specific data for each of those individual queries. If we scroll down here and we click on the select customer order SQL query, that's going to open a performance detail for that SQL query in a new tab, and it's going to give us the information specific to that SQL query. Now, you may see that all of the values that are showing are the column names. There aren't any values in those column places. That is by design. Retrace masks the value of SQL calls to protect our client data, and that is one option as far as security that we do not allow to be unmasked. So Retrace will mask your values to protect your data, and it's just to ensure the security of all data that's being processed. Below that, we're going to get some individual reporting on the SQL query that we're viewing. The query execution count versus average time just gives us an idea of how many executions of this query have there been, and what are the average load times for those requests. And then below that, a usage by calling action. So that will break down this SQL call is happening from this action and however many more actions it can be called from. That allows you to see disparities in SQL calls when called from different endpoints. The next tab of APM information is going to be your external web service calls. They're going to be listed out by their specific URL. As an example here, we've got a sandbox API with Azure websites that we use to simulate external web service calls in our sandbox. And we can see that it's picking up Get albums in our test application. We can see, again, just like we do with server requests, what percentage of time have they been called? How many calls were made to that specific external web service call? And then how did those calls perform on average? Again, for this first one, for Get albums, they're called 47.3% of the time. Just about 2,000 calls were made in the last 4 hours. And on average, they performed very well at 0.002 seconds. The last item for APM information specific to categories is going to be tracked functions. Tracked functions allows us to dig into the sub-transactions occurring in that larger overall function and get you APM data from that information. So essentially, track functions allow you to dig into those sub-transactions using a configuration from our documentation that's very easy to integrate into your code, that wraps the overall function, allows you to name that function specifically so that you know what information is being reported on. And then once that is all configured, we'll begin reporting back to your APM tab under tracked functions and give you information just like you would see with your server requests, but for specific functions occurring in your code. The next tab is going to be the servers tab in APM. And all the servers tab is a cumulative reporting of APM from each of your servers. And then the last tab in APM is going to be trace data. This is going to be a listing of all the traces from all the endpoints, from all the requests and actions in your application that have been reported in the time frame that we're viewing. So any trace that was sampled and deemed context worthy to report to your Retrace account is going to show up in this listing for this application. Now, the last thing I want to talk about in our session today is some common troubleshooting issues that we see oftentimes in our support queue when it comes to APM and clients that are just configuring APM for the first time. One of the most common items we get is I've installed the agent, I've configured my .NET app, but I don't see any APM yet. And a lot of times, this most common issue is not really an issue at all. If the application that you're configuring to report APM for is not receiving traffic automatically, you're going to want to generate some manual traffic to that application for about 15 minutes or so to get started. There's going to be a 10 to 15 minute delay for the initial APM reporting. Once our service gets that APM uploaded, that delay becomes much, much smaller. After the initial reporting of APM, you can expect to see traffic that took place now in about 5 minutes. Another common issue that we see is people will install Retrace on a Windows machine and not restart IIS after the initial installation has succeeded. That restart of IIS allows our profiler the ability to attach. It requires that clean restart so that we get a new process ID and allow the agent itself the opportunity to attach that profiler. So if you install Retrace and you skip the step for restarting IIS and you're trying to get APM, you've got everything configured, and you realize you didn't restart IIS, that's going to be your go-to. One other common APM issue we see, this one's going to be specific to Microsoft, to Windows machines, is when clients have what we call a co-create issue. And all a co-create means is that more than one profiler was found. So to resolve that conflict is going to mean uninstalling the other tool, uninstalling Retrace, restarting IIS, that reinstalling Retrace and restarting IIS once more, that will clear up the conflicts that the co-create has created with there being more than one profiler installation, and should get APM reporting correctly for you. Thank you everybody for your time today. It was my pleasure to take you through Retrace. I love doing what I do. I love teaching people about Retrace. I love supporting the tool for our customers. And I cannot say enough that if you're using Retrace and you run into any questions or you run into any issues that you need assistance with troubleshooting, our support is second to none. We pride ourselves on how we support Retrace. We encourage you to reach out to us, even if you think the question is small and not important. We're here to help. It's as simple as sending an email to support@stackify.com, or you can even submit a ticket through your Retrace UI under the help option. Again, thank you for your time today. I hope that you learned a lot about Retrace APM. I hope that you're enjoying All Systems Go. Thank you for attending the Nugget user get together for 2022. Have a great day.
Bye.